Now let's get started here. I'm going to be talking about the mineralogy of a pegmatite located in the pyroxene syenites of the Stettin complex in the Wausau complex, Marathon County, Wisconsin, in central Wisconsin. Authors are myself, L. Foster, and Skip Simmons. And the Stettin complex located up here is the oldest, roughly 1565 million years, and most alkalic and least silicic of the four intrusions that comprise the Wausau cyanide complex. And the pegmatite that we're going to be talking about is located here at the red star in a body of pyroxene cyanide. And there's several bodies of that material scattered about in the intrusion, along with tabular cyanites, nepheline cyanites, amphibole cyanites, and other phases. And the pegmatite is located in this field, located northeast of the intersection of County Highways U and O. And recently, two local collectors received permission to dig a small excavation to recover samples of anorthoclase, which is in demand as quote-unquote Wausau moonstone from small pegmatites in the field. I was able to examine recovered material and study the accessory minerals. And here is a sample of the moonstone or anorthoclase showing the color play that is what it's being sought for. This is uncleaned. It is other than being simply washed off and wetted to allow us to see the color play. And what part of the excavation, as shortly after beginning, and here's pegmatite here, and over here is more simple cyanite. And you got a shovel for scale. And further on in the process, they're down quite a ways here, about 5 going on towards 6 feet. They're getting close to the ultimate depth, which was about 6 feet. And the small irregular pegmatite or pegmatites is hard to tell in the field because of the ubiquitous rusty stains and clays, but they seem to be roughly horizontal, relatively thin, and of limited width. This dike itself is zoned. Intermediate zones include altered former pyroxenes with remnant Heidenbergite, arfvedsonite with minor rebecite, clear pink to orange zircons, altered rhabdophane CE, and other accessory phases. Core zone material is mostly anorthoclase with arfvedsonite and accessory minerals. Minerals are present but small. Sporadic surface finds of large clear quartz crystals in the vicinity suggest larger minerals must also be present. There is no central quartz core per se. Quartz is not uncommon in this pegmatite, but it has not formed, at least as far as I have seen, a distinctive quartz core. The mineralogy that we've seen to date is indicated here. A couple have been determined subsequent to submission of abstract as graphite and davidite CE. Others we're a little uncertain of, or there are questions regarding what did they start out as, for example, and you'll see what I mean a little bit later on. Permidaris and Kohlner pyroxenes in the Stettin complex range from iron-rich diopside to Heidenbergite and aegirine. Aegirine is absent in this pegmatite, and Heidenbergite is only present at this time as sparse remnant grains and altered replacements. Probable former pyroxenes, Heidenbergite and perhaps diopside, but we have not found any diopside, but it might have been there before, once upon a time, are abundant and now largely consist of soft smectite-like replacements and sparse aggregates of vesicular ferro and thophyllite. We suggest many pegmatite minerals, not all by any means, but a number of them, have been affected by late-stage oxidizing fluids, altering Fe2+ rich pyroxenes to Fe3+ rich smectite group clays, plus or minus Fe3+ rich arfvedsonite and rebecite, with sparse remnants of Heidenbergite. arfentonite, and riebeckite appear to be later than the pyroxenes. Calcium released by pyroxene alteration may have contributed to the formation of various late-stage calcium-rich species, e.g. calcite, fluorapatite, and calcium-rich synchosite or pyroxene. Rhabdophane CE may have been affected by this late calcium flood, as abundant elongated hexagonal crystals, small but quite nice, except some problems with them, showing good rhabdophane morphology, now largely consist of a soft, crumbly, high calcium phosphate material with variable light rare earth elements that may be partial fluorapatite replacements of former rhabdophane. Grains of probable chevkenite group minerals are common but invariably altered with highly variable compositions suggestive of chevkenite or perhaps periorite group species. Aconite CE is not uncommon in core zone material but easily overlooked due to the small crystal size and association with arfentonite and other dark phases with which it is easily confused. Some visually identical crystals have been recently determined to be davidite CE, further adding to the confusion. Bavenite. Small white bladed crystals included as inclusions in one sample of clear quartz crystals are strongly suggestive of bavenite, and that sample is from float in the field. Lack of exposure of the bavenite and owner reluctance to having his sample broken up to expose crystals preclude further analysis at this time. Davidite CE is visually indistinguishable from aconite CE. Cerium is the only rare earth element detectable in davidite CE versus the usual palette of light rare earth elements, lanthanum, neodymium, praseodymium, in aconite CE, indicating the cerium is present as Ce4+, suggesting formation or alteration under oxidizing conditions. Fergusonite Y is common in small, tapering yellowish to reddish-brown prisms in anorthoclase, arfentonite, and in small minerals. Echorite, well, we're not sure that's what it is, but we have one small grain of a calcium tin aluminum silicate that was found in heavy mineral separates. And if it's not echorite, it's something else interesting, but we're trying to find more. And here's what some of the stuff looks like. Zircon here is penetrated by rhabdophane, a white elongated grain penetrating the zircon. We see that quite often where the nice euhedral rhabdophanes pass right on through the zircons proceeding from anorthoclase into arfentonite or whatever. And what came first, the rhabdophane or the zircon? Here's another zircon, but this one is unaffected apparently by rhabdophane in anorthoclase and arfentonite. There's a fergusonite in here that is kind of shows a little bit of reddish brown internal reflections. An altered zircon, probably metamict. Most zircons in here look quite clean and are probably not metamict, but some exhibit this chalky appearance and apparently are metamict. There's several generations apparently of zircon in this dike. Here we have some nice little transparent zircons penetrated by white, soft, chalky looking rhabdophane, or whatever it ultimately winds up being. And here davidite CE with fairly high manganese contents. So now you see also what the aconites look like. Anyway, and here's a gray-brown zircon, euhedral. And a fergusonite Y located here is dark grain. And here's the same fergusonite Y, but in backscattered electron imaging. And ilmenite is quite common in this pegmatite. Most seem quite fresh, but there's also a bunch that have been altered to fine grain anatase or rutile or whatever. So, and here are my references I have cited, and these are also listed in the abstract. And that concludes what I have to say.